Good day to all. Today we are going to see about that methods for making a single phase induction motor as a self-starting motor. As we know already, this single phase induction motor not a self-starting one. So how we can self-start with that single phase induction motor? These are the methods to make a self-starting. First one is slip phase induction motor. Then capacitor start induction motor, then capacitor start run induction motor, saddle board induction motor, and a permanent slip capacitor motor or single valve capacitor motor. See split phase induction motor. In addition to the main winding or running winding, the stator of single phase induction motor carries another winding called auxiliary winding or starting winding. As we know already, see already there is a one winding in that single phase induction motor, that is called main winding. Instead of that, now we can say extra from that one winding is added to this motor, that is called here auxiliary winding or starting winding. A centrifugal switch is connected in series with this auxiliary winding. See, if you are seeing the diagram, you can see over here. This is the main winding, and we will get the auxiliary winding over here. So, a centrifugal switch, this is called the centrifugal switch. This is the centrifugal switch. A centrifugal switch is connected in series with the auxiliary winding. The purpose of this switch is to disconnect the auxiliary winding from the main circuit when motor attains a speed up to 70 to 80% of that synchronous speed. Because see, here we are using this main auxiliary winding only to start up that particular single phase induction motor. After starting that, we no need of that auxiliary winding. So in order to disconnect, we are using that centrifugal switch over here. If the motor gets 70 to 85% of speed, then it will go for that synchronous speed to maintain that particular speed. So after that time, the centrifugal switch disconnect from that auxiliary winding to that this single phase induction motor circuit. Then we know that the running winding is inductive in nature. But our main aim is to create a phase difference between the two winding, and this is possible if the starting winding carries a high resistance. Let's say I run is the current flowing through the main or running winding. Then I start is current flow the starting winding, and Vt is a supply voltage. Then we will see that phase angle over here. In split phase induction motor, this starting winding and main current get splitted from each other by some angle of this motor. Then it name as a single phase induction split phase induction motor. So you will see here, this is the I start, this is the IT, again this is the I start. Here it is a Vt into IR. This is the way the split phase induction motor used as a self starting for that single phase induction motor. Then we will see the another type of that single phase induction motor, which is capacitor start induction motor and a capacitor start capacitor run induction motor. Here this IM is denotes that induction motor. See, this is the black diagram of that capacitor start induction and capacitor start run induction motor. Here you can see this is the starting winding, this is the main winding and capacitor over here, and this is the centrifugal switch, this is the squirrel cage rotor, this is the main winding. See, this main winding is already there in that single phase induction motor. We have to add this start winding over here. Then there is a centrifugal switch is there. This is the schematic presentation of that single phase induction motor with the capacitor start and the capacitor run induction motor. This is the phasor diagram how the voltage and current is to be in that particular induction motor. See, the working principle and the construction of this capacitor motor are most of the same. As we know already, the single phase induction motor is self-starting because of that magnetic field producing a non-starting type. That's all we already know that. In order to produce the rotating magnetic field, there must be some phase difference. If we are giving the phase difference, then the rotating magnetic field produced. Here, in case of split phase induction motor, we use a resistance for creating a phase difference, but here we use a capacitor for this purpose. See, in split phase we use that resistance for creating a phase difference, but now we are using the capacitor. So in capacitor start induction motor and the capacitor run induction motor, we are using two windings, the main winding and the start winding. These are all the two windings we are using here in this capacitor start and the capacitor run motor. And see, with the standing of this winding, we connect the capacitor. So current flowing in the capacitor, that is IS leads and apply voltage by some angle of pi into ST. You can see over here. See, if you are giving the supply, then via this capacitor, this starting winding will make a rotation of this main winding. If this rotor will make a 70 to 80 percentage, then this motor will act as a single phase induction motor as a self-starting. Then that time the centrifugal switch may be cut off. Even though if it is cut off before that motor makes that 70 to 80 percentage, this capacitor over here, this will give the supply to this starting winding. So we will get this supply from this starting winding. Whereas in that split phase, we are using the capacitor. Where we are using in the split phase, we are using that resistor. Here we are using that capacitor. That is the main difference between that capacitor start induction motor and the capacitor starts capacitor run induction motor. There we will have a centrifugal switch and the resistance over here, but here the capacitor over here, because if it is any damage or any power cut during that after on time, then this capacitor will act as a current, then it will give to the current to the starting winding. Likewise, we will have a self starting of that three-phase induction motor. Thank you.